Let's solve this equation. Notice this equation contains rational expressions. Notice I already factored the first denominator. It was x squared minus 25, the difference of two squares. So here it is in factored form. Remember, our first step is to multiply through by the least common denominator. Keeping in mind, by the way, that x cannot be, a solution cannot be 5. 5 makes this denominator 0. A solution cannot be negative 5. Negative 5 makes this denominator 0. Same thing here. X cannot be 5 nor negative 5. So remember that as we multiply through by the LCD is x plus 5 times x minus 5. So let me see if I can make this as neat as possible. But it is x plus 5 times x minus 5 times this rational expression, 10 over x plus 5 times x minus 5. Now I may end up going around on the second or the next line, but don't let that confuse you. And by the way, there should not be equal signs there. I'm working with my equation. My equal signs go right here. Next, same thing, x plus 5 times x minus 5. Now that will be times what? Times this term, 3 over x plus 5. And then we'll continue on so it doesn't get too wide, plus, again, x plus 5 times x minus 5 times the last term, 1 over x minus 5. On your paper, you may want to write it straight across so it doesn't get confusing to you. But now notice how nice it gets once we simplify. That divides out. That divides out. We are removing factors of 1, and I have just 10. And that is very, very nice. Is equal to, and then watch what happens. This divides out, and I have 3 times x minus 5 plus, okay, and just so you'll see that whole entire line of equations so you can see it, because I'm going to write a little further down to keep things straight. Plus, what happens finally then? What divides out? The x minus 5s divide out, and we have what? 1 times x plus 5. And look how nice this is once we multiply through by the least common denominator. Now, let's go ahead and use the distributive property. That's 3x minus 15, 3 times 5, plus 1 times x is x, and then plus 1 times 5 is 5. Let's go ahead and see if we have any like terms. 3x plus x, that's 4x. Negative 15 plus 5, that's negative 10. Then we add 10 to both sides. 10 plus 10 is 20, is equal to 4x. How do we finish solving? We divide both sides by the coefficient of x, which is 4. And it looks like our proposed solution is 5. Now, why is this in fact not a solution? Remember, let's go back up to our original equation, and we talked about the fact that x cannot be 5 because look at your rational expression here. If x is 5, you have 1 over 5 minus 5. That's 1 over 0, which is undefined. Now, that only has to happen once, but in fact, it occurs here also. This does not check. X cannot be 5, which means this equation has no solution. This equation, in fact, has no solution.